Hi guys, this is just a quick little debrief video of the activity we did last time, the random assignment activity for discussions. And what I did is I actually have two Math 115 classes this semester. So I combined the results from all of you guys and I basically compiled it onto this little spreadsheet here. So the results that I recorded were the number of A's that were left of center and number of A's that were right of center. And by the way, I didn't write this down, but the B's would be opposite, right? So if there's four A's left of center, that means there's four B's, right? This is more illuminative. There's four A's left of center. That means there's four A's right of center. It also means there are six B's left and two B's right? So it also tells you about the B's as well. But anyways, coming back to the experiment debrief, let me just answer the questions with you guys. Starting with what are the experimental units and what are the treatments? So the experimental units in this case would be the land plots that you guys, represented by these randomized squares that you guys picked out and then you plotted in the discussion post that you made on our Padlet, right? So what are the experimental units? Those are the treatments are replied. The treatment is applied to those land plots. So land plots are the experimental units. And what's the treatment? The treatment is whether or not the land plot received the Kupao moon phase, right? So if the kala was planted on Kupao or if it was planted on some other different moon phase. You're trying to determine if planting on Kupao makes actually an actual difference for the outcome. Okay, number two, why do you think it's important to randomly assign the moon phase to the plots? And would it have been a good idea to use moon phase A on the plots on the left of the diagram? So looking back to the diagram, if I put all the A's on the left, would that be smart? And the answer is no, because you have this water here and the big trees, right? So there's a good chance that the location of this water might have some confounding variable effect. It might be the case that it causes these land plots to grow better, but you don't know if that's because of the location of the water or if it's because of the being planted on Kupao. So that's a confounding variable. You want to eliminate that by doing random sampling. And so random sampling, the whole point of it is to get rid of that confounding variable there. Okay, so let's see. We did the task. I recorded the tallies. Let's see the results. So first, here's some follow-up questions, blah, blah. How many land plots with moon A were left of center and how many were right? So here I have the recorded results and dun, 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 let's see what they were. Total left of center. So I combined results from both of my sections. 198 left and 202 to the right. So look at that. That means it's only a difference of four out of about, if you look at the total, this is 202 plus 198. That means there's 400 total A's, and only four more of those 400 ended up on the right side. That's 1%. Four out of 400 is 1%. So very, very close, in other words, right? And we didn't predetermine, how many we are going to put left, how many we are going to put right. It just randomly came out almost exactly even. And the other thing I want you guys to notice is that if you look at some of the individual results that you guys had, like some of us had things like 3 and 5s, or there were, oops, I just changed that. There are some instances of like 2 and 6, or vice versa, 6 and 2, right? But in the end, it all kind of balanced out when we combine everyone's results. So anyway, answering this question, left would be 198, right would be 202. Question number two, similar. How many land plots with moon A were above the center and how many were below? So I did that again. And also very close. This one's slightly different, but only a difference of five. So slightly over 1% of the total moons were to below the center as opposed to above center, right? So 1% more. So in other words, almost exactly even again. And again, this is totally random, right? Okay, answering them. Question number three. Did your random assignment result in an approximately even split left and right of the vertical line? What about above and below? And the answer to both of those is yes, approximately even, without any pre-planning, right? Without any block randomization or anything like that. Okay, number four. In experiments, random assignment is used as a way of ensuring that the groups that receive each treatment are as much alike as possible with respect to other factors that might affect the response. Explain what this means in the context of this experiment. So in the context of this experiment, that other random, I'm sorry, the other confounding variable would be the water here on the left, or maybe these trees at the top, right? So those are two things that we should be aware of. So in the context, we want them to be as much alike as possible. Much alike means in relationship to where they are located to the river or to the trees. Okay, lastly, number five, suppose that at the end of the experiment, the mean yield for one of the moon phases is quite a bit higher than the mean yield for the other moon phase. Explain why it would be reasonable to say that the moon phase is the cause of the difference in the yield and not the proximity to the river or to the northern trees. And so the answer to that is it would be reasonable because we have a pretty even split for the number of land plots that receive the moon phase A to the left of center, which would be closer to the river, and above center, which would be closer to the northern trees, right? We basically an even split, so that's not really a factor because both groups are treated pretty fairly as it pertains to the location of the river or the northern trees. The last thing, guys, that I want you to really note here is that when we did this randomization, we had no idea. We did it basically blind of where the trees were when we did the actual randomization, right? So even without really specifically targeting where we're gonna place those land plots, it just kind of came out that it is basically fair with relationship to those two factors, the river and the trees. So what that means is even if there's some kind of confounding variable that we're not aware of, that's outside of our vision, by doing random assignment, we actually can account for that because randomly assigning it is gonna make sure that it's roughly gonna be even without us knowing what those confounding variables might be. Now we could have done block design if we wanted to specifically target, the left and right, and maybe separate this like these four uh each of these four quadrants into blocks and make sure that there's two A's and two B's in each of those four corners, and then randomly select from there. That would have been a block design, and that maybe would have targeted these up and down positions better. But it turns out it's not really even that necessary. By just doing pure random assignment, we basically accounted for both of those factors, right? Okay, guys. So in your discussion post, just post a reaction to this whole thing. What were your thoughts? And maybe reiterate anything that stood out to you or anything that you learned from this. All right, and I'll see you guys when I see you guys. All right.